Welcome to Quantum Kinetics Corporation. I'm your host, the CEO, and today we have Dana Kippel, the Plasma Queen, to demonstrate today. What are we doing?
Hey guys, so my name is Dana Kippel. I'm obsessed with plasma, and we're going to see the real-life Arc Reactor. Tony Stark, Iron Man. We're going to watch this man of quantum kinetics break fusion records. Real, guys. This is the real deal.
That's right, Dana. We're going to go ahead and hold 150 million degrees Celsius temperatures using the Arc Reactor technology, also known as safe nuclear energy systems. And we are extremely excited to demonstrate with you today.
Yay. And I do have a question. Is this cold fusion?
Yes, we're actually going to show you that we're going to hit about 2.5 electron volts to the Arc Reactor.
Okay.
And you're going to see temperatures that are in the 10 keV to 5 keV regions, which science says you can't do that. To make that kind of X-ray, you have to have the equivalent electron volt snapping action. But we're going to show you today cold neutron flux, which is safe nuclear.
And this is basically about the same or even less power than it takes to light a light bulb, which is then pushing out the power of a supernova.
Yes, we're going to be detecting basically the X-rays that the cavitational event, which is AKA gravity, pulling in using the electron extraction technique, using this, and you'll be able to tell us what the power level is over there.
Oh, exciting. Can't wait, guys.
So yeah, let's go ahead and get started. And we'll go ahead and run through each one of these pieces of equipment, and that way you have a better understanding.
Woo!
Before we begin, Dana, and we break a record in plasma fusion for our audience, we have to tell everyone what everything is, just so they know. So what you're looking at is the reactor, the Arc Reactor. This is an XR100CR X-ray detector. It's what they use in NASA to detect black holes and everything like that. That signal goes into an amplifier, which then takes the small X-ray signals and grows it big so the pico counter can see it. And the pico counter goes to the computer and shows us what's going on.
Got it.
And you're going to be in control of the power, so you're going to turn the knob to get some fusion going.
And just so I'm clear, this is kind of like Inspector Gadget with a magnifying glass of the X-rays, feeding it into his brain.
That perfectly explained. Absolutely.
Great.
Couldn't have done it better.
Lovely. And I will be...
And you'll be turning the knob.
I will be God.
I mean, technically, kind of.
To Inspector Gadget,
You're
at least.
basically like a deity.
Yes,
You're not quite God, but...
Yes, I'm an archetype.
So what is the power watt meter reading right now with everything just on and idle?
Right now it is 4.4 watts.
Watts, very good, yep.
Yes.
Okay, so before we even begin good science, we have to calibrate our detector, first thing. So we have a piece of iron 55 radioactive substrate right here. Which you
radioactive.
This is radioactive. This is emitting a soft beta and is trying to turn into manganese 55.
It is trying to decay, is what he's saying.
Right, and so what we want to do is we're going to turn on the detector, and we're going to take this radioactive sample and put it right in front of the detector. And so it is, in fact, detecting beta X-rays.
Which means it is decaying. So basically, the NASA thingy over here, not the Arc Reactor, is reading that it is, the iron is decaying into whatever word you just said.
Manganese 55.
Manganese 55. Great. Got it. Understood.
So this is now calibrated because we can see that we've got a very strong characteristic X-ray emission in the iron 55 decay range.
So that reads the X-rays emitting from the decay of the iron.
Correct.
And what is it saying that it is?
So it's about, there's a characteristic at 5 and then there's a characteristic at 6.2.
And then 6.2.
So this is exactly, it's like a fingerprint identification of what that is.
And is it the 6.2 or 5, is it hertz or what is it again?
So that's in kilo electron volts. So that's the photon's energy punch. That's how fast it's coming out.
Photon energy punch. Interesting.
Yes.
Okay.
So,
which is consciousness. I'm the photon. I'm just kidding.
So then we'll do a new one. So that was background.
Okay.
And so now we're going to go ahead and turn it up.
Okay.
And I'll let you know when you hit 10 keV, which is 100 million degrees essentially.
Okay.
And then you can just stop the voltage gain.
And then turn it off?
Oh, don't turn it off. Just leave it there.
Okay.
And then you're going to tell me what the wall meter is reading.
What the watts going into it is.
Correct.
Okay, got it.
So are you ready?
Yes.
You're going to break a record today. Ready?
Yes. Breaking fusion records.
Okay, you ready to turn the knob?
Yeah.
Okay, we're going to go ahead and start.
And
Go
you'll
ahead.
tell me when I'm at 10.
Yep, go ahead. Turn it up.
Here we go!
Keep going. Okay, you're at 3.5.
I'm going slow.
You're at 5.6. Okay. You're at 7. You're at 8. You're at 10 keV. You just broke plasma record.
Woo! And it is at 5.1 right now. 5.1 watts.
So that's basically 0.6 watts of power from the wall going into powering an LED light, a speaker, in an open circuit. This is an open circuit capacitor to the air.
Just so you guys know, it takes like 12 watts to power a light bulb. Yeah. And this is 5.1.
And we are sustaining plasma fusion safely. All right, so you
kind
can
of
go
a song. Okay.
You can go ahead and turn it down.
Bye-bye, plasma.
Okay, and so what we're going to do is, now that we got the spectrum, you can kind of see that we have a very strong characteristic at 10 keV, which means something's happening in the universe where it's actually turning into something else.
What is turning into something else?
It's decaying. The air itself is decaying. And we could look at a chart, which we have, which we'll do later, but this indicates, each one of these peaks indicates a very specific thing that's occurring in this region.
Yes, yes. So basically, just like when you put the iron to it and it read that decay, this is reading the air's decay. So whatever is in this invisible air is decaying, and it's reading that.
Correct. And then what we'll do is we'll go ahead and make a new one and then start it up. And the X-rays, there's not there. You're not even turned up, and it's not. There's no other, you know, nothing like this behind it. Nothing like that.
So this is almost like a fourth dimensional portal to the inside world of plasma, or the invisible air.
Well, actually,
or
if you want to talk about that, we'll go ahead and stop it, and then we'll go to the experiment that we did with the Arc Reactor. This emission spectrum right here at 3.55, this characteristic peak in astronomy, no one really knows what that is.
3.55.
3.55 keV, and the theory is that this is an antimatter agitation. Antimatter being that the another dimension is being agitated to cause our dimension to recoil.
Interesting.
So that's why we can do such low power fusions, because we're tickling another dimension.
Like almost like the other side of the mirror, like the singularity. And interesting.
Well, that's what this is. It is a singularity.
Yeah.
Just like a black hole, or just like a star, or anything else.
Or like mini black hole. This guy talks about mini black holes and atoms. So basically everything that's creating us like a hologram is like a bunch of black holes creating the universe.
Yeah, so that's kind of like Richard Feynman's theory about the one electron theory.
Yes, yes, yeah.
So Richard Feynman had a concept, and he didn't really like talking about it because it's kind of out there, and that's kind of where this technology is too. It's a little bit out there, right? And that's why we're demonstrating it for you. But Richard Feynman's theory was that one electron can turn into a proton, and that proton then can turn into a neutron, and you can actually go back the other way, turn the neutron into a proton, and then the proton can turn back into
By
an electron.
what process?
Well,
did he say?
He didn't say what it was, but there are theories that it has to do with quantum tunneling effects, where two electrons will quantum tunnel into a proton.
Yes.
There are theories about that.
Interesting. That basically we're in a hologram. Where things can be transmuted, which is what you're literally doing.
Right, and the amazing thing about this, Dana, is that, yes, this is plasma fusion, sustained safely. But what is it good for? Well, it's good for propulsion, clean energy propulsion. It's good for electricity generation. It's good for cancer treatment research for new isotopes, wink. It's good for radioactive waste decontamination and transmutation of uranium-234, 235, and 238. We can crack uranium and turn it into thorium, tungsten, and even lead.
So how can you explain the process about how you clean the air or water with this.
Right. So you can, just like what we saw here,
Yeah.
the atoms are actually turning into something else. So if
Yes.
you were to blow CO2 gas over this,
Uh-huh.
it would actually transmutate the CO2 gas into something else,
Got
carbon
it.
dioxide.
Got it.
It would turn it into something else at low power, which is
Yeah.
the big problem with CO2 sequestration, is that the fans to blow the air takes a lot of energy,
Yes.
which is using coal.
Yeah.
Then the transmutation electrolysis that they try to do in there, which is not very effective, it's sort of effective, that takes a lot of energy too, because it's basically just standard electrolysis. This is not that. This is different.
Okay.
Powerful.
So basically what they're doing is kind of a, I don't want to say the word hypocrisy, but they're using a lot of energy to get rid of it, almost like a publicity stunt, where this is actually really helping the world.
Right. And it's actually a viable energy solution, right? Because the amount of little tiny bit of energy we're using to make this process happen is so revolutionarily new and innovative that this platform can be used for every industry today. Everything.
So what's the next step? How do you get there from here?
Right. So we have spent 7 years doing research with the Department of Energy and other top national labs and isotope companies. And we have spent 7 delicate years of research and making sure everything's properly done before announcing this. And so the only thing necessarily that this needs is funding. It's the only thing that stops it from
create more of these things on a bigger scale.
Correct. I mean, the technology is viable. Technology has been research verified, and it is time to deploy and build.
Okay, so what do you say to the jerk scientists who say that this is impossible, who are very close-minded? Not all scientists, just the jerks that say it's impossible.
Well, I would say that you can't call them jerks. I mean, they're...
Oh my gosh, sorry.
You can't call them. You got to be nice. You got to be nice.
Well, I'm nice. I think they should have an open mind.
They should. So there's a philosophy is like...
They're calling you a jerk.
They are calling me very nasty names, but here's the thing. You have to be kind.
Yes.
You have to have love.
Yes.
And you have to have understanding.
Yes.
Because
very true.
You can't let your ego get in the way of good science.
Yeah.
And if you don't believe what you see with your eyes, then you might as well hand over your PhD, because that's what science is all about, is about observation.
So you're kind of saying, hey, jerk scientists, you're not jerks. I get why you doubt this. This is very new. I want to help you understand it in a loving, curious way, not force it down your throat, and join me in this journey.
Right, because all of us can benefit from this technology, Dana. All of us can really have a better, clean Earth. There are things about this technology that we don't even disclose because they're so amazing and so revolutionary.
Can't wait to hear that.
Yes.
To hear more of that.
I'll give you a little teaser. So when you think of like someone drawing a picture of a utopian place where everyone's got fusion, what do you picture? Like in your mind?
What do I picture with this, or what do I picture in the mainstream of how they think of it?
Like when people portray fusion, how do you?
So I think when people portray it, they portray it more cyberpunk, which is, you know, very mechanical. I see it. I think where you're going with it is more solar punk or star punk, which is more biological. Which, if you want to get into it, you can. But I'm not going to say anything else.
So like what you're
nature
saying,
friendly.
Correct. So if you look at a picture of someone drawing fusion on a spaceship or something, they have a utopic green, blue, like utopic place. Right? Where everything's growing from the fusion device.
Yes.
Literally.
Yeah.
And that's actually what does happen. When you do it right, the universe actually, for every action, there's an equal and opposite reaction. When you push Mother Nature to the limit, she gives you special things.
Yes.
Which I can't really talk about specifically, but it does. So, but it is here. It's
I want you to expand on that.
I know. I wish I could.
So when
Maybe when the camera's off.
Damn it. Okay. Interesting. I feel like I have more questions. Okay. Can you explain a little bit, because I think people want to know this and I want to know this. Can you explain a little bit about what X-rays have to do with plasma? Yeah.
So X-rays are a renormalization event with the nucleus of the atom. So the core has a proton or neutron, and there's electrons flying around it, right, in an orbital. So when the electron falls in from the K, L, M, N orbits, every time it drops,
Mm-hmm.
it emits a photon
Mm-hmm.
as a renormalization. So the K, which is super close to the nucleus,
Mm-hmm.
when it drops in, it emits an X-ray because it's actually
When it
transmutating.
drops in the nucleus.
Yeah, the electron drops into the nucleus, turning into something else, and it has to emit an X-ray, which is what we see here.
So it's literally like a plasmatic thing, these electrons. There's an interesting theory that this guy told me and on a podcast about that birds in mythology symbolized electrons, and they were the song of plasma, and they were the great electrons, or birds were the great communicators of plasma. What do you think about that?
So birds are interesting because their voice box is a resonator. And what that means is when they push air through their larynx, essentially, they are basically creating a very special pitch that they can modulate up and down, or, you know, frequency modulate. And that's exactly what we're doing here. We have a resonator or cavity.
So there's like a bird larynx.
It's totally like a bird larynx,
Okay.
or a T-Rex or anything like that, right?
Interesting. So you're singing plasma's song in a contained way.
With a flower. It's basically a flower design.
A flower.
The way the plasmoid energy swirls around.
Yeah.
Because the way the coils are arranged, it actually causes a vortexing action.
Like the flower of life.
Correct.
Or a siren, perhaps, that scared the sea people, but it shouldn't have. They want you to be scared because they don't want you to know the siren's magic, like he's keeping from me right now.
Well, until we get rolling and get moving, yeah, we kind of have to be a little bit secretive about it. But yeah, the thing about technology like this is that we have eyes, but we don't see. We have ears, but we don't hear. We had to create a speaker so you could hear the electricity.
Yeah, yes, because you can't hear it otherwise.
And then we had to have a very special detector detect the X-rays, which you can't see with your eyes.
Yeah.
So to see fusion, you never see a color because it's too energetic. If you see purple in your reactor, you're doing it wrong.
Okay.
There is, in astronomy,
there
is no purple stars. If you have purple in your reactor right now, you are doing what's called a nebula fart. It's just hydrogen gas bubbles.
So what is it really? It's colorless?
Fusion is colorless because fusion, the safest fusion that actually only gives you more energy out than put in, is harnessed through a negative field.
Yes. Oh, this makes so much sense. I'm just okay. You keep talking.
Negative field into a coil. The electrons are falling into this well, the quantum well. They're falling into it, and as they fall into it, just as we know in Hawking radiation, that positrons emit.
Is this Hawking radiation?
Kind of.
Okay. Okay.
It is it's acting.
Kind of. Yeah.
Like one.
Like it. Like
synthetic.
Like a black hole a little bit.
Yes.
Yeah.
And I'm going to tell you another thing that most people don't know about astronomy is that a black hole,
it emits and pushes out.
A black hole does both.
Yes, yes.
It's a push-pull-tug relationship, just like you know, any relationship with anyone.
Yeah.
There's always a give and take, right?
Black holes are a flower of life. They're a feedback loop.
That's right.
Yeah.
And there is a balance that is struck between the circuitry and the environment.
Okay, interesting. I want to say something about the colorless thing. So once again, I think that has to show with like what's on display or a show or theatrical versus reality. So I forget, we'll have to look this up, but some physicist said something about, they called plasma the mythical beast or the colorless, dimensionless beast. But I think it's really interesting because it's kind of, it's a ghost.
It is totally a ghost because you can't, like, can you see gravity?
No. Can you see love? The same thing as plasma.
Can you see your immune system working?
No.
These are all things that involve a higher dimensional flux.
Which is why you're asking scientists to have a little bit of faith.
Correct. Because you can't measure antimatter really. There is a way to see antimatter through a cloud chamber. Are you familiar with what a cloud chamber is? So it's basically a box that has vapor alcohol mist in it, and it's really cold. And there's a condensate in the air, and then high energy particles will fly through it. And as it flies through it, it makes a vapor trail.
Okay.
Periodically, you'll see a vapor trail that does a swirl.
Oh, yes.
One way and then the another way.
Okay, yeah.
And that is the electron swirling one direction, and then the positron, which is the antimatter, swirling the opposite way.
Interesting.
And what's even more interesting about that cloud chamber swirl is that in the observation, you see the electron swirl less than the positron. The positron has more energy.
It has more swirling.
It has more swirling. So the positron energy is greater than the electrons.
Oh, that's so interesting.
So there's a pressure that is always there pushing up. It's called the Dirac sea. It's actually a Nobel Prize winning concept by Paul Dirac. He's the one that actually discovered the positron back in 1934.
And why does that make the positron more?
Because there's a thing called self-energy. There's a fancy word for it called Zitterduium. It's a German word for electron swirling. And basically the matter-antimatter relationship of the spring coefficient, which we talked about in other videos on YouTube, is that the spring coefficient is driven by the antimatter, which gives the electron this weird kind of wobbling, like Heisenberg uncertainty. We don't know where it is. Like if we try to measure its energy, we're like, okay, we kind of know its energy, but we don't know where it's located. It could be anywhere.
But the positron is more logical or masculine, and the electron would be more feminine and receptive and maybe,
Well, there is definitely a charge duality between the two. So the electron's negatively charged, the positron is positively charged, but they're different mass charges.
Yeah, okay.
One is negative, one is positive. Now, I would say, based on the masculinity or the femininity or feminism, is that the positron that's positive is sucking in.
Oh, okay.
The positron is female.
And what would you say, just for everyone watching and to freshen my memory, what is a positron in relation to an electron? Because so there's protons and electrons, but what, just for people who might not know, what is a positron?
A positron is a conjugate charge of the electron. So it is an electron, but it's the opposite charge of electron. Okay. And it's actually going backwards in time.
Okay, interesting.
And the electron's going forward in time.
Okay.
So that's what's interesting about the universe, is that it's a stream going one way and a stream going the other way, and it's joined together. The streaming update function of the universe, time, is updated by the two, crossing each other. Okay. And so when you influence one, there's a recoil.
The other ones, so which is a literal feedback loop once again. Okay, so let's say I would say the electron is feminine and the proton is masculine. In this feminine electron, there is, which I always say this in my TikToks, a masculine and a feminine within everything. So in that electron, the positron is actually the more feminine quality.
I would say yes, because positive, it's pulling in. And because it has more energy, it can give. So it's what a feminine would do. A feminist would do that. Like, that's an innate characteristic.
This is reminding me of a Taurus too. I feel like everything is a Taurus.
Well, the electron is a Taurus, actually.
Yeah. Okay. That's what I think as well.
Taurus, so.
Okay. Or a Vessia Pisces. Pisces, I don't know what it's called.
Yeah, the Vesca Pisces or something.
Yeah, I feel like it's this two-dimensional Taurus, but interesting.
Well, there's a crossing, right? The Vesca Pisces or whatever, it has a crossing point between the two, which means, and here's an interesting question for scientists and everyone out there is, what is the average gravity of an electron? And what that means is if you were to put a pencil on your finger and you had to find the average gravity or average weight of an electron, where is it in equilibrium?
What would you think? Like, what do you think about that question?
Well, it's definitely not equal.
Yeah.
It's leaning one way just a tad bit.
You think okay, because the positron,
because the positron has slightly bit more energy.
So that
which is what causes the expansion of the universe in general.
Hold on, wait, my brain. So the positron, you're saying, what was the question again you asked the scientist? What is the what of the electron?
What is the average gravity of an electron?
The average gravity of an electron. And you're saying because there's a little bit of a tilt towards the positron or the feminine, ha 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 ha. Just like mothers do end up giving birth, guys. I mean, it's a two-person show, but mothers do give birth. So.
Yeah, and nourish.
Yes, yeah.
That's another thing.
I like to personify everything, and I think everything you're saying can actually be personified into everything is a reflection, and I think that literally how families work and how men and women look, if we apply this to everything you're doing, it might open up some new answers, which I'm sure you already know, but scientists can start maybe thinking of things as a holistic family, but that's just my opinion.
So when you look at this is a histogram. This is the actual photons rising up.
Okay.
So this is all positive photons. Now, when you do this with the reactor on, it will periodically show up as negative photons down here.
Oh.
Now, if we go here to the actual experiment,
it'll show those negative photons.
Now, this didn't really we didn't turn it up very loud at all, actually. But, and by the way, we didn't put water on this. When we spray water on this reactor, it actually does warn negative photons.
Oh, wow.
So what I'm trying to get at here is that this reaction actually triggers, can trigger when there's water present, it will trigger a negative response photon. So there's positive photons and there's negative photons.
What does that mean in terms of, because I have a theory that I've not put together all, but that photons have something to do with consciousness. Just like kind of like electrons have something to do with plasma. What would you say when you're applying this consciousness thing to negative and positive photons? Like, what does negative and positive photons actually mean, if that makes sense?
Yeah, so a positive photon would be emitted from the electron's renormalization. It's moving. An electron will move in space and it'll emit a positive photon.
Yeah, what's a negative photon?
A negative photon is when the agitation of the antimatter happens first.
Okay, so it's more a reaction of what's happening from this underbelly area.
And then it emits a negative photon.
Oh my God, okay. So if our consciousness was at two places at once, that would make sense what it's communicating with, but that gets into metaphysics.
It would be interesting, Dana, to actually have analysis of the brain's chemistry and the way that the electrons are moving in the brain and to see if there were any negative spikes. Like with the heartbeat on our video for Quantum Kinetics Corporation, we start with a heartbeat of a galaxy explosion. It drops down first and then it jumps up.
Like jumping. You have to bend your legs to jump up.
They call that in athletics the penultimate jump.
Okay.
The pre-jump.
Yeah, yes.
So you get low to high.
So you're saying that's what might be happening in the brain, where we're dipping into this antimatter negative consciousness first, and then having the positive consciousness or photon. That's kind of what you're saying.
It's possible. We'd have to do more research on that, but I would say that nature's mechanism is the most efficient way.
Yeah,
And if we're seeing nature's mechanism as in negative photons when we spray water on this thing, that's a big indicator. Correct. That's nature's pathway.
So I would say my theory on that, just a theory, is that right now we have been built in a survival mode where we don't dip our consciousness into that antimatter or plasma area first. So, or ground of being. So I almost think we almost have logic before we take in our environment. So I think that would be reflect more indigenous cultures where you sense everything around you first, or dip your consciousness into that underbelly, and then you have positive consciousness or photons, or logicalize what you're sensing. But I think we're doing it ass backwards right now.
Yeah.
But that would kind of reflect what you're saying.
So positive energy is attractive. Like if you have a good aura, positive energy, that's what they say. And like you're attracting people. You're like, oh, I'd like to hang out with that person. There's an attraction field, a positive charge there where the electrons want to be. It's like having an atmosphere around Earth or something. There's a positive charge that's holding the electrons around Mother Earth as our atmosphere. And during the electrons flow in that pathway, they turn into ozone and nitrogen and all these other things. And so you get this boundary layer that you can breathe, and it's a protection blanket. But you have to have a positive charge holding it there.
Interesting.
And the more CO2 that we incorporate into this bubble, the more it becomes loose. Because CO2 is not really that chargy. It's kind of hard to make it break.
And when it becomes loose, what does that mean?
It becomes, the atmosphere wants to kind of weep away. Kind of like Mars. Mars had an atmosphere and it weeped away. It's still kind of there.
When you take away the positive charge. That's like my tattoo with the positive in the middle of two negatives.
That's right.
That's what you're saying.
That's right. Which is Very important, actually.
How can you apply this to psychology? Basically, what you're saying is that, what are you saying? I feel like I just figured it out. Okay, so when we're more in that positive state, that's why people want to be around us. Mm-hmm. But people kind of disperse every time our mind dips into a more negative way of thinking. That mm-hmm. kind of is what you're saying. But how is that applied to this?
Is that this is actually pulling more of a positive charge than it is a negative charge.
Okay, so this is a friend.
And
friendly
it's
friend.
Pulling in the electrons.
Okay.
And then once they get pulled in the circuit, it basically causes a complete it's like, do you know what a fire hydrant is?
Yes.
Outside?
Yes.
So a fire hydrant mm-hmm. can actually do this thing called a cavitation, where let's say a fire hydrant can push out water at 300 gallons a minute.
Yeah.
Which is a lot of water. But let's say a fire engine comes up and hooks to it, and that fire engine can pull 600 gallons a minute. And so the engineer spools up the turbine on the truck, and it starts sucking 300, 400, 500 gallons from this hydrant. What happens is the pipes start to squeeze, the concrete couple breaks down, and then the water just goes boom, and it cavitates, and the entire hydrant will fall.
And what does cavitate mean?
Cavitate means it just falls in on itself.
Oh, okay.
And so the hydrant is being sucked so hard that the universe goes, it just falls in.
Okay, wait. Okay, I have a great analogy for this too that I think will help people like me or the everyday person. So, which maybe I am, maybe I'm not. but either way, a part of me is. So my question is, so this is a friend. This is your friendly friend, Sarah. And she is very positive, and all of these friends want to be around her. And when they're close enough around her, their lives change. They transmute, like what is happening with the air. So then when they transmute, when it's being pushed out, how would you kind of describe that in my analogy? How do the friends change? Do they go some type of process where they become more like Sarah, or do they become more like their individual real selves in the antimatter universe?
So in astronomy and in physics, there's a graph called the atomic energy nuclei bonding force. And when you do fusion with light atoms, like hydrogen and helium, they all start to go up towards this thing called iron. Okay, they start real low and then they go up. And
everything goes towards
everything that's light, like oxygen, or I think sulfur might be. And it just all starts going towards this high peak, which is the most stable thing, which is iron.
Oh, like our blood. So they're trying to become humans.
That's a great point, actually.
Yeah.
And then on the higher side, where there's like uranium, tungsten, all these gold, what happens is it starts up really high, but then it starts going up higher towards the iron. So what that means is during transmutation, everything is trying to find stability atomically because of the arrangement, and it always goes towards iron, which is the most stable. It cannot be penetrated, and it shields up Scotty from Star Trek. Like the atom is like, hey, you can't break me. My own gravity charge is so strong, you can't touch me.
Okay.
And that's why iron is such an amazing metal, is because it kind of is like super strong in a way.
So you're saying when they're being transmuted, they're all trying to get closer to iron.
To be more stable.
So,
just like our society.
Like harmony and balance.
Right. Society always wants to be stable.
Yes, they're moving towards equilibrium.
But right now, we don't have a focal point. Right?
We don't have a goal.
Right, we don't have a collective goal.
Interesting. Okay, so basically everything it's transmuting here are literally trying to become humans. I just want to let you guys know that. So we're more special than we think, in my opinion. But this is basically not exploiting, but this is helping these little plasmas transmute closer to iron, basically. In a way, almost it's helping them maybe become their authentic selves or balancing. Interesting.
So do you have any questions, Dana, that you can think of that?
Yeah, so kind of what you were going back to. Okay, so your goal obviously is to get this out to the masses to help your pinnacle, your iron. What is your iron? I'm going to interview him. I'm going to become the host for a second.
That's fine.
What is your iron?
Iron Man.
Yeah.
Make the suit.
Oh my God, Iron Man. That just clicked in my head.
There you go.
Did they know that? I
Yes,
wonder.
of course they did.
But what is with this? What is your iron? What is your North Star? What is the highest dream for the Arc Reactor for the world?
So I'm not allowed to say what that is because that's in development right now.
Oh.
But I will just say this.
Give us a Orion constellation give us near a North Star.
I'll put you to general vicinity. It's basically the full Iron Man suit.
To what?
The full Iron Man suit.
So it's to make us interdimensional travelers.
That's a bit of a, well, now why do you say that?
I think if we were to have an Iron Man suit, we would be able to do that, and maybe not exactly with our bodies perhaps going somewhere, but I think putting on the suit would maybe make us receive the places we could go in our consciousness in a way where we are traveling, but not traveling at the same time.
So to go on that is that this technology, Dana, is the beginning step platform for bending the second law of thermodynamics, which means
is wrong.
Well, it's half right and half wrong. So
okay, tell me.
So entropy, the second law of thermodynamics, says that everything starts at some energy level and then decays out into its lowest stability form. Which, yeah, in a room without heaters on, it will just be at equilibrium, sure. But that's called dampening systems. Dampening will dampen out like this. That's okay. The second law of thermodynamics says that everything must go into a lowest state of entropy, which is lowest energy state. But here's the thing. Like we were talking about before, the antimatter or positron has a little bit extra energy than the electron in a room, right? So if there's a way to, and this is called Maxwell's demon theory.
Oh, that goes to the machine.
Yeah, it's the demon that is a portal door opener or closer to two different rooms. One that has hot and cold.
Oh, so it's the demon in the middle of the torus.
Correct.
Or the crystal. It's really not a demon, is it?
So, and this is where the metaphysical concepts that you have meet the actual science that we have at Quantum Kinetics, which is we have synthetic devices. Basically, if you want to call it a Maxwell demon, that triggers the bending, I'm not going to say breaking, but bending of James Clerk Maxwell's Maxwell demon, which breaks the second law of thermodynamics. More energy is emitted than put into it.
Oh, like a gestalt in therapy. It's where the whole is more than the sum of its parts.
Yes, very similar to that.
Okay, so because there's more energy putting out than being taken in, which would not be possible technically, but is possible. It's kind of like almost like survival mode where you can lift a car where you never thought you could. That's the way I can kind of do it in my head. It's like your body intelligence takes over, your plasma intelligence takes over. So in this plasma intelligence, more can be outputted than is being inputted.
Right.
And where's that coming from?
And exactly. And that's why scientists are they're really upset right now, or with me especially.
Because it doesn't make sense.
It doesn't make sense because you can't measure antimatter very well. You can't sense antimatter very well. All these concepts that come from this reactor are from another dimension.
But does superposition make sense?
So, well, why don't you tell can you tell the audience what superposition actually is?
I believe, and maybe I'm wrong, but the way of my understanding is if there's an atom here and then a million miles away, if I scratch this atom here, it feels the scratch a million miles away because they're connected in some way.
So that would be a quantum entanglement.
Quantum entanglement. But wait, what is superposition?
Superposition, which, by the way, they're very related.
Yes, I know what it is, but you have to tell me because I can explain.
Yeah, so quantum superposition is when it's just like a transistor.
One is negative, one is positive.
Yeah, you can turn on an electron or turn off an electron with a transistor. It's like a gate of water, on, off, on, off.
So it's in superposition means
What it means, superposition means is the electron, this is what happens in quantum computers.
Yes,
they turn the electron off and on at the same time.
Yes, okay.
And it doesn't know.
Yeah.
It doesn't know what to do.
Yeah.
And so the universe goes, there's a void here. I got to fill it in.
And it has to collapse by our choice.
And this is also a wave function collapse as well.
Yes.
This is Penrose stuff.
Yes. So superposition, sorry guys, wow. Superposition is more holographic in terms where, yes, you're at two states at the same time. And you, like in psychology, if you were to make a conscious choice, that wave function would collapse and you would observe it, which would make that thing happen. But there's ways metaphysically, I won't go into that, but interesting, yeah.
Yeah, and so...
How is that, what were we talking about, that I just said that?
That this device, being a synthetic $40 toy that has been modified, this device mimics what the universe does and what happens in our bodies, in our hearts.
It reflects nature.
It is a reflection of nature.
Which are the best inventions.
Yes, the golden ratio. So like Nikola Tesla talked about how he did his transformers were all golden ratio. He would weigh the wire, and then he would be primary to secondary has a ratio. And you have to maintain the boundary conditions of the ether, which was taken off the periodic table in 1900s-ish, which is kind of
ether is plasma.
Ether is plasma.
Just so you guys know. Michelson-Morley experiment was flawed, but we won't get into that right now. Wait, but
Do you want to know why it was flawed?
Yeah, I can guess that I don't even think they just had the right testing materials to test what they were testing. That is my idea. They didn't know. They don't even have the right measure.
So let's go back to the experiment that you just did, Dana.
Okay.
So you turned a knob that changed voltage, right? You went from 0 volts up to 2.5 volts. Do you know that the voltage at ground level is a certain number? And if you go 10 feet up in the air, the voltage goes up 100 volts.
I didn't know that, but that makes sense.
And you go another 10 feet, you get another 100 volts potential difference.
Okay.
Now, Michelson-Morley, they did their experiment on a flat table, and then they rotated it.
Okay.
The voltage didn't change in that space, so they couldn't detect the ether. But if they were to put it up on its upright like this, that was 100 feet long, like the interferometers and all that were 100 feet long, and turn it like a merry-go-round or whatever, or a Ferris wheel or whatever like that, you would be able to detect it because remember, the voltage that you change here influences the ether.
So can we prove with some experiment in the future, I would love to show my followers, maybe yours, that, so I have a theory that plasma is the vehicle for consciousness, or we can also say it's the vehicle for light or photons, just like they said luminiferous ether was the interstellar medium for light, but they couldn't prove it. Would we be able, with what you're saying, to maybe prove that in some way? In the future.
In the future, yes. I will say this, that there is a limit to the observational world that we can perceive.
Yeah, for sure.
And like, for example, a neutrino goes faster than the speed of light. And there are objects that do actually, in fact, go faster than the speed of light. I mean, if you have a Cherkov radiation inside a nuclear reactor when there's water present, the blue light glow that you see, that's the radiation going faster than the speed of light. That's electrons going faster than the speed of light, and they emit the glow.
Oh, the luminescence.
The luminescence, but it only happens when there's water around.
Interesting. Well, the cosmic ocean, we're all in water, we just don't know. Yeah.
I think it was Carl Sagan that said something along the lines of that the universe is our cosmological ocean.
Oh, yes. And they also said it, there's mythology. I don't know if it was the Hindus, I'd have to look it up, but we're literally in an ocean. That is the primordial waters of plasma. Okay, so I asked you about your North Star. You can't tell me, but your Orion's Belt dream for this is to make an Iron Man suit of some kind?
So in the Iron Man franchise, the suit is able to generate its own electricity from the Arc Reactor. It's a power supply for the suit. Now this emits radiation and does use a very small amount of power, but you can tweak this in just a very specific way where you can actually get a lot more energy out in terms of electrical energy.
Oh.
And so the big thing for this movement, Dana, is having this technology be used for electricity generation, clean propulsion, just like the repulsor technology of Iron Man's, you know, with his palms and flying and all that.
Yes.
All that technology can be integrated into the platform industries that we have currently right now without hurting the market.
Okay.
This is what's so important is everyone's afraid of this new technology because it's going to destroy the markets we have. That's actually false. The reality is this is actually going to grow the existing markets tremendously.
Okay.
And make a lot more jobs because there is building that needs to be done.
So there's a lot there. Okay, let me start with this and then no, hold on. Okay, the Iron Man suit thing really quick. Just so basically you're saying that one of the end goals with this to create an Iron Man suit is basically that someone would be able to have a wearable technology like this and perform superhuman feats, correct? That is what you're
right. That basically miracles, right? I mean, like when you're a 6-year-old boy and you watch Iron Man for the first time, there's something inside your soul that goes, this is it. Like, I know this is important.
Like this might be possible even.
Yeah, that this is possible. And now it is possible.
Yeah.
And it took someone to go off the beaten path for 7 years and lock themselves in a garage, which I did because of a very bad car accident. And so to do this and follow your 6-year-old self is what is hard to do on planet Earth.
It is. But it's the only way to really live, guys, going back to your childhood dream. So this is your childhood dream. That is amazing. Let's get more into what you were saying now. I want to talk more about the Iron Man suit, but I know you can't say that much. So
I'll do my best.
Well, because I was trying to think really quick about the Iron Man suit. So basically anyone would be able to wear this and, you know, possibly perform feats of, oh, I want the bag of Ruffles across the room, let me get it to me. That is like the silliest way to use it. And then it could also be, you know, that police could wear it in the future and help save people under cars that have crashed and lift it and get those people out of there in a better way where people could have died, correct?
Exactly. So like mechanical, electrical pistons or drive motors or whatever can use this technology into an integrated suit to give you more power to lift or push.
Anti-gravity.
Or anti-gravity-ish stuff. So as long as you can figure out a way to collect all this extra energy, because by the way, this is extra energy.
So
all right? This is just coming off of this thing like a star. How do I use this for good?
And put it in a suit.
And have it be electron flow or some nature. There is a way. Okay, and that's what this new platform is all about. It's taking this flower of life, which works, and then engineering it so it can actually be put into a Tesla car, or put it into a home generator, or whatever else, right?
Yes.
Or an Iron Man suit.
Interesting. Okay. And I also see the flower of life as the flower of life, flow-er. Interesting.
So this is not electrolysis.
Yes. What is this? This is not electrolysis. What is it called?
This is called the Quantum Kinetic Well phenomenon.
Okay. And explain a little bit about the actual well phenomenon.
So the well phenomenon is a known concept in semiconductor science, quantum computers as well. So what happens is when an electron falls into a well, it has to have a certain amount of energy to get out of the well. But what we do is if you have a little bit of electrons slushing around in the well back and forth, you ever been in a bathtub and you're like swishing the water like with your legs, and then it almost like the water starts making your legs want to move too, even though you're not doing it?
Feedback loop, yes.
It's a feedback loop.
Yes.
And so the semiconductor creates a feedback loop on itself in the well. Thus, the boundaries are jumped with little power input.
It's like a complexity machine. Where it's constantly feedbacking on itself to maybe emerge new properties.
And new states of matter.
Emergence. It's an emergence machine.
Exactly what it is.
Emergency. I'm just kidding.
Well, we are in an emergency situation right now.
That's a good one.
We're running out of time. We're running out of time to make a big impact on saving Earth.
Why do you need to rush this to market? Why do we need the money now and not in 5 years? So please don't take us out to 5 steak dinners and ask a bunch of questions. Listen now.
Been there, done that already.
Yes. Why do you need it? Why do you need people's faith?
Well, it's not really faith anymore because it's
Trust.
actually science, right? Like it's actually, research verified, it works.
And why do you need to rush it to market?
Well, the reason we need to rush it, and I don't want to call it rushing because
or get it
to market as soon as possible, get those milestones, is because we are actually, just look at the climate crisis. Florida just got hit with 2 ginormous hurricanes, one after the other. People's lives are decimated. Billions of dollars to go and help from FEMA, billions.
Which is costing America a lot of money.
That costs you and I and everyone else a lot of money. And so by deploying this technology quickly, we actually are saving ourselves money in the long run. It's called being preemptive versus proactive, or retroactive, I should say.
Could this be sent into a hurricane and take some of the moisture out of it and lessen a hurricane? I'm just kidding. I feel like that would work, but anyway.
You wouldn't want to do it in that method, but
there's a way.
Yes.
There's a way to, I think, lessen or create storms with this technology.
Well, it does. Okay, so if you were to see what the electrons were actually doing here with the coils, the way they pulse, it actually does cause a swirling action.
Okay. Oh yeah, a vortex, which has to do with plasma as well.
Actually, when you create a vortex, Dana, you're actually amplifying the ethereal matter of fine matter. You're amplifying it.
Interesting. Okay,
That's
so
why
the vortex...
spirals have...
And what creates the vortex? Is it the photon or consciousness?
It's a pressure differential.
Okay.
Just like a high front versus low front in weather.
Okay.
So a high front is like high pressure pushing up, and low pressure is pushing down.
I like positive and negative.
And it's a gradient, like a voltage.
Interesting.
And so when they collide with each other,
that's what causes it.
There's these
that's like the
renormalization events.
Oh my, sorry, that's like the dipoles in a microtubule. How it is the electron cloud between the dipoles, where one's positive, one's negative, creating a vortex of plasma and consciousness. Okay, interesting.
Well, and here's another thing too.
This is the same thing.
It's the same thing. It's the same mechanism done in a very synthetic method.
And by synthetic, just for people who don't know, what does that mean?
Synthetic just means like you can touch it and it's actually like there.
Yeah.
Or it's man-made synthetic. Like drugs are synthetic drugs because man made it.
If you wanted investors and people to know the top 3 interesting and useful things about this, what would you say?
I would say that it's energy generation in the form of electricity.
Okay.
And it's also transmutation of radioactive waste.
Okay.
That doesn't exist. There's no platform for that right now.
Okay.
Transmutation, those are the 2.
Okay.
It means that this technology...
Related back to this, yeah.
Yeah. It means that our technology that we have discovered here allows us to now take new paths that are not on a specific plane.
Of least resistance.
Now we can take every path.
And how?
Using the quantum computer effect, which is the superposition of the electron. When you put the electron into superposition with this device, which is the quantum computer, by the way, it means that now time is having trouble updating. It can go forward in time and backwards in time, and that's why this is able to break uranium.
So can this slither around? So can this almost freeze time and slither around, or make it in a gel and slither around like a little electric eel, just like curiously looking at all of them, and it doesn't need to collapse it into a path of least resistance. It can take
all paths.
It can take all. So it can take multiple paths, but it can also choose like one path that's not the path of least resistance that it likes. Is that what you're saying?
Yeah, and you can There is a way also to focus that.
Yeah. Okay. There is a way to.
There's a way to focus it.
And I would love to know how to apply that to my own freaking brain. I think my brain might do that already a little bit, but but I think that's when we're bring it back to demon or
Maxwell's
daimon. That's when you're really connected to your soul or connected to your inner genius. What some people would like to call demon, but really it's relying on yourself or your inner genius. And this is relying on its own inner genius. But how can we do that as humans?
So the way to change the world and just bring it back to that we're all in this together all of us,
Mm-hmm.
we have a problem,
Mm-hmm.
and we have an energy problem.
Mm-hmm.
You know, we can't have third world countries have the same experiences we do in our country because it's just too much of an energy burden.
Yeah.
So we have to figure out a way to efficiently use our technology in a way that is not destructive, but creative and efficient
For the whole world.
for the whole world. And then once
The
we
water.
do that, which we can do that with this technology, it just needs to be built up.
That's what literally needs. We need funding for the infrastructure. Then it will kind of take care of itself.
Correct. And then what's going to happen is then we're going to realize that the most important thing in the entire universe is our relationships with each other.
Yes, relationship.
In conjunction with the universe. Because this is using the same mechanism that your body's doing right now.
Relationships and feedback systems.
And we're all connected.
It's all talking to each other.
We're all communicating with each other. And if we stop communicating improperly with each other and start being filled with hate or misunderstanding, then the world starts to fracture. And so this technology represents bringing everything back to the core, which is biology, astronomy, electricity, and love.
Yes.
That's what this is all about.
This is the glue. This is the plasma glue.
It's going to bring us all together.
Yes.
And
no one be scared of that. Even the people with fear who are scared to lose power. I think I think everyone's power won't be lost. Everything will actually expand, like what he's saying. There's unlimited power, but you're holding on to it because you're scared you're going to lose it. But if anything, this won't take the power away. This will amplify your power, but also give it to other people, which is fine. Relax.
Yeah.